Hey guys, we're going to be doing thermochemistry in this video, specifically calorimetry and phase change. Let's start with this simple problem. Calculate the heat required to raise the temperature of 40 grams of water from 5 degrees Celsius to 90 degrees Celsius. Oops, that should be a period, not a question mark, but whatever. So we can start with our equation. Q equals mc delta T. So Q is the heat, M is the mass, C is the heat capacity, and delta T is the change in temperature, which is temperature final minus temperature initial. So let's plug in our values. We're trying to find Q, and we know that the mass of the water is 40 grams. The specific heat capacity of water is 4.18 joules over grams times degrees Celsius. And the delta T will be 90 minus 5 degrees Celsius. So we notice that the grams here cancel out, and also the degrees Celsius cancel out too. So we're left with 40 times 4.18 joules times 85. And this gives you 14,212 joules. So now let's move on to a more difficult problem. 17 grams of iron is heated to 450 degrees Celsius, then dropped into a beaker of 45 grams of water at 22 degrees Celsius. How much does the water temperature change? So again, we have our equation Q equals mc delta T. But this time, it's more complicated because we have two objects in our system now, the iron and the water. So what do? We want to find delta T, which is the temperature final minus temperature initial, but we don't have the temperature final. But we do realize that this system of two things, the iron is super hot and placed into the water. And by the concepts of thermodynamics, we know that the heat in this iron will continue to transfer into the water until they reach an equilibrium, which is until the temperature final of the iron is equal to the temperature final of the water. So that also means that the heat of the water will equal the heat lost by the iron. So that's why we need that negative sign here. So now we can replace these heats with the actual mcat equations. So the mass of the water times C of the water times delta T equals negative mass of iron times C of iron times delta T. And we can plug in the values that we know. We have 45 grams times the specific heat capacity times T final minus temperature initial, which for water is 22 degrees Celsius. And this is negative 17 grams times the specific heat capacity of iron, which is 0.45 joules over grams degrees Celsius. And this is times temperature final minus 450 degrees Celsius. So we can cancel out our units again. And we can do multiplication and the distributive property. So we have 188.1 times temperature final minus 4,138.2 equals negative 76.5 temperature final plus 3,442.5. And this is 195.75 temperature final equals 7,580.7. And dividing this gives us 38.726. And if we want to apply sig figs, this will become 38.7 degrees Celsius. So now we have the temperature final, but this is not the end. The question asks for the temperature change. So delta T, which is temperature final minus temperature initial. And now that's pretty easy because we can just plug in our values. So 38.7 degrees Celsius minus 22 degrees Celsius equals 16.7 degrees Celsius. And so that is the answer of delta T. Now let's move on to a phase change problem. Phase change is just tricky because you need to divide the problems into multiple sections, but the calculation part is actually pretty simple. So let's read this problem. Calculate the energy needed to heat 23.0 grams of ice at negative 46 degrees Celsius to water at 90 degrees Celsius. So for these problems, it always helps to draw a graph just to complete your understanding. So let's do that. We have the time here and the temperature here. So we start at negative 46 degrees and we will have a landmark here at 0 degrees. And then we want to continue until we reach 90 degrees. So the ice we have will continue warming until it reaches 0, which is the melting point for water. So here it will plateau because it's undergoing the phase change and melting, and at this part the temperature does not actually increase. After it finishes melting, it will continue to rise in temperature until we reach 90, which is what we want. If we were to continue until 100, it would start plateauing here again because this is the boiling point. But we don't need to worry about that in this problem. So we can divide our graph into 3 sections. We have A, the first part where it's warming up, B, where it undergoes the phase change, and C, where it's warming up again, at this time as water. So in parts A and C, the kinetic energy and the temperature are both increasing. And so we use the equation we've used before, Q equals mcat. But in B, it's actually the potential energy that's increasing, and the kinetic energy and temperature don't. So we use the equation heat equals delta H times moles. And we have multiple delta H's. We have the delta H of fusion, which is when a solid turns into a gas. And for water, this is 6.01 kilojoules over mole. And delta H of vaporization, which is liquid turning into a gas, which is 40.7 kilojoules per mole for water. So now let's start doing our calculations for each section. For part A, we are going to use Q equals mcat, and we can plug in our values. The mass of the water is 23.0 grams times the specific heat capacity, and since it's ice, the heat capacity is actually 2.1 joules over grams Celsius, and this is times 46. So this gives us 2,179 joules. Now let's do part B. this time we will use the new equation Q equals delta H of fusion times mole. And we're using fusion because we're going from solid to liquid. So we have Q equals 6.01 kilojoules over mole times the moles. But what is the molar mass? We can find this using the atomic masses given on the periodic table. We know that water is H2O. It has 2 hydrogens and 1 oxygen. The mass of hydrogen is, to the nearest whole number, is 1 AMU, and for oxygen it is 16. So since we have 2 1s and 1 16, the total molar mass of water is 18. So 1 mole of water will have 18 grams. And we multiply this by the number of grams that we have, which is 23. So we can cancel out the moles and the grams, and this gives us 7.68 kilojoules. Now we can do the last section, part C, again using Q equals mcat. So we have Q equals 23.0 grams, and the heat capacity of liquid water is 4.8, and this is times 90 degrees because that is the amount of temperature we're increasing. So this gives us Q equals 8652.6 joules. So we want to add all of these up to get the total energy needed. But notice that part B is in kilojoules and these two are in joules. So we could either convert B into joules or the other joules into kilojoules. And I think the latter is a better idea because they are already pretty big numbers. So this would become 2.18 kilojoules, and this will become 8.65 kilojoules since there are 1000 joules in a kilojoule. And now we can finally find our delta H total by adding parts A, B, and C. So this is 2.18 plus 7.68 plus 8.65. And that gives us 18.5 kilojoules. So this is the answer. So as you can see, it's pretty simple, and it's more tedious than anything having to divide it into so many parts. Okay, so now let's go on to the last problem in this video. It's a different kind of phase change problem. So find the amount of ice needed to cool 125 grams of water at 21.5 degrees Celsius to 4.0 degrees Celsius and have no ice left. So let's start by writing down our equations. We have Q equals mcat, and the other one, the phase change one, Q equals delta H times mole. So water is definitely going to use this equation because the water is getting cooled down, and ice will definitely use this equation because we want it to undergo the phase change and have no ice left. But the final temperature of the water is this one, and if they are in thermal equilibrium, then the ice will have to reach 4 degrees too. So that means after the ice melts, it will also be heating up a little, which means we need to use this equation for the ice as well. And we know that the heat that the water loses is equal to the heat that the ice gains. So here we can have the mcat of the water is equal to the heat of fusion times the moles of the ice and the mcat of the ice to get to 4 degrees after it melts. So we have the mass of the water is 125 grams times the specific heat capacity times delta T, which is 4.0 minus 21.5 degrees Celsius. And this equals heat of fusion, which we know is 0.1 kilojoules over mole, times 1 mole of water, which we found previously, the molar mass of water is 18 grams. And we want to multiply this by the grams of ice. So we can just call that M for now, because that's what we're trying to find. And we also need the mcat part. So this would be mass times the specific heat capacity, which is we use the one for liquid water because at this point the ice has already melted, and times delta T, which is 4 minus 0 degrees Celsius. So calculating the stuff on the left side, we get 9143.75 joules. And on the right side, we can factor out the mass and calculate the stuff inside. We can change this to joules because the specific heat capacities are in joules while this is in kilojoules. So we have 6,010 joules, and since these moles cancel out, this is over 18 grams. And the other part here, the Celsius degrees cancel out, so we have this is a plus, sorry. We have 4.18 joules over grams times 4. And now all of these joules can cancel out. And we can just do this in a calculator, but at the end, you get that the mass is 26.1 grams. So that's the end. And this problem is pretty easy to calculate once you figure out what equation to write. So I hope this helped you guys. That's it for this video, and remember to sleep and study.